Hey everybody, in this video we're going to talk about finding the final amount in a word problem on continuous exponential growth or decay. Before we talk about this problem, let's talk about what the model for exponential growth or decay looks like. So here's our model. It's a function in terms of time. A is the amount at that time, or the final amount. A naught is the initial amount, kind of like P when you have P e to the RT, right? It's like our initial principal, but in this case we're not talking about principal necessarily. E is a particular constant. It's actually called Euler's number, so it's E. R is the rate of growth. Okay, if we're a positive R, it's growth. If we're a negative R, then it's decay. And T is the time. So for this problem, the number of bacteria in a certain population is predicted to increase according to the continuous exponential growth model. So that means continuous exponential growth or decay, we use A, or our final amount, is going to equal our initial amount times E raised to the RT. We have a rate of 15% per hour. So R is positive because we're working with growth. So R is equal to 0.15. Suppose that a sample culture has initial population of 99 bacteria. So our initial amount, or A0, A naught, you might hear it called, is equal to 99. Then it says find the predicted population after 2 hours. So T equals 2. So our final amount A is going to be A naught, our initial amount, times E to the R times 2, which is equal to 99 times E to the 0.3. After we do this calculation in our calculators, we will get 133. Oh, it says round to the nearest tenth, so this is going to be 0.6 bacteria. So we started with 99 bacteria after some growth, and 2 hours we have 136.6 bacteria. Okay, so that is the continuous exponential growth model. Let's look at a problem where there's decay. So we are told that we're working with a continuous exponential decay model in the problem. So we are going to work with A equals A naught times E to the RT. A biologist has 9,595 gram sample of a radioactive substance. Okay, so that means our initial substance is equal to 9,595. Find the mass of the sample after 4 hours. Okay, so time is 4. If it decreases according to a continuous exponential decay model at the rate of 12%. This is where we have to be a little bit careful. Because it's decreasing, that means our rate is negative. So R is equal to negative 0.12. So when we plug it into our equation, A naught is 9,595. E is a constant. R is negative 0.12 times T, which is 4. Why is it important to include that negative? Because if we didn't, we would get an increasing amount, but we have a decreasing amount. This equals 9,595 times e to the negative 0.48. After we calculate that, we will get that we have 5,937.2 grams. Always go back and think of it in the context of our problem and what we are told. We are told that we are decaying. We are going from a bigger amount to a smaller amount. That is what decay means, right? Did that happen? Yes, it happened. So I know my rate had to be negative. If I ended up with doing a positive rate, I would have gotten a higher number, and that is not going to be a decay model.